So I want to echo, first of all, Peter's thanks to Richard Snee and his team, because it's just phenomenal what they've done pulling together an event like this in 6 weeks, and it sort of represents the velocity that this whole space is moving at, so I commend Richard and the whole team. I also wanted to sort of add a story to the sort of the coolness of data science and data scientists. I have a 19-year-old son who's a freshman at college, and as probably all of you know who've got teenage kids, it seems like part of a teenage kid's job description is to make their parents feel uncool. Well, this weekend, my son, who's studying economics, came up to me and said, "Dad, I think I want to be a data scientist." I'm now cool again. We're all cool. He doesn't even know what I do, as most kids don't. So I was like, do you know what I actually do from day to day? Anyway, what I wanted to do today was, it was sort of an interesting question and request and invitation from Richard. It gave me an opportunity to sort of take a step back and say, what have I and what has Karmosphere learned from 2 years in the Hadoop space, working with kind of some of the low-level open source contributors, working with this emerging ecosystem, and working perhaps most importantly with the early adopters, the customers and users of Karmosphere products. So what I've tried to do in the materials I've pulled together is to say, how can I distill what we've learned into a set of sort of justifications for Hadoop, into a set of maps and frameworks that allow you to think about sort of all these new things that you learn about Hadoop, and a set of lessons that as you move into working on big data and hopefully evaluating Hadoop, things that will help you move faster by standing on the shoulders of those early adopters. So first of all, let's just talk a little bit about the business context for this, the opportunities and challenges. You can't turn a corner here in the Venetian Hotel, or you almost can't turn a page on the web today without seeing this phrase, big data. So we know that data's got big, and there's all kinds of evidence and sort of backup information for that. You only have to look inside your internal organization to figure that out. But one of the things that the big data term sort of misses is the fact it's not just about the scale of the data, it's about the type of data as well. And Pete earlier was talking about, look for sort of undervalued, I think, data. And unstructured data is often sort of the undervalued data in the organization. And the fact is that's growing, I think, 5 or 6 times faster than structured data. Many people are concluding that the answer to working with large amounts of data and any type of data is Hadoop. But the question that some of the questions I want to help you answer is, why? Why are people reaching the conclusion that Hadoop is important? Why should you believe, some of the hype that there is around Hadoop? How should you think about it? And how do you do something with it? How do you get started? A little more framing. This is a diagram that, interestingly, our CTO came up with. He's in the audience here somewhere. But I shared with Paul last week, and Paul was like, this is creepy. I just created the same diagram at Booz Allen. But we think it's sort of important when you think about data to think about data in 2 vectors. Number one, it's not just about scale, as I mentioned. It's also about the degree of unstructuredness of that data. But it's also, as you guys know, it's also about the sophistication of the analytics that you can apply to that data. And if we think about the world before data got big, it was about sort of small data initially and either small, sort of unsophisticated analytics or more complex analytics on that small data. But as data got big, even with Moore's law, and that vertical dotted line sort of represents Moore's law, even with Moore's law enabling sort of multi-threaded, single CPU, highly complex analytics to sort of move along, it can't keep up with the pace of data. So my theory, and what we're seeing from customers in terms of the conclusion they're reaching, is that in this age of big data, we also need big analytics. So I want to share with you just some sort of data points, because people say, and it's easy to look at this thing and call Hadoop and think, well, it's hyped, and I'm hearing big data, and I'm hearing Hadoop. Are people really using it? So I went back into our organization, looked at what data that we've got, because we have a free product we've had available for 12 or 18 months, and we try and mine that data as a company that's in the data space. So this gives you an idea of the kind of industries that are using Hadoop. And we continue to track this data. But you'd expect the technology companies to be doing things. So many of you will know that this whole Hadoop thing was kicked off by papers that Google wrote, and then Yahoo and LinkedIn and Twitter and Facebook's infrastructure is built largely on top of Hadoop. So we kind of know that. But what's starting to happen now is the sort of consulting companies, both small and large, like Paul's, are staffing up. They're building service organizations, stacks of products and technologies that help enterprise organizations. So that's not surprising. But what does surprise a lot of people we talk to is how many different vertical industries are actually getting into Hadoop. And so many of the people in this room, I imagine, sort of sit in some of these industries. So take note, and I'll come back to that point later. We've sponsored some research recently with an organization called Ventana Research, and they shared with me some of the preliminary findings, so I thought I'd reveal some of this today. So again, this sort of helps, I think, in how you think about justifying sort of a move to Hadoop in your organization and some initial prototyping projects. But in over 50% of organizations who have big data, people are either about to get into Hadoop or already using it. And people are already confident from what they've learned that they can do things with Hadoop in the organization. And it's not about, and we've learned this over the past 12 or 18 months, it's really not about sort of throwing out everything you've already got. It's not about throwing out your skill sets, your hardware, your software. It's about adding it to that organization. And I'll show you kind of how data fabrics are emerging to house Hadoop in a moment. And the other thing that's important to think about with Hadoop is that it's not just about taking what you do today and kind of scaling that up. It's about being able to do things you couldn't do before, to build new capabilities, new products and services based on that data. So watch out anyway for this research. It'll be published shortly. So let me talk you through kind of the fabric. One of the things we've learned, again, over the past 12 months is when people hear this word Hadoop, they throw a lot of things in that bucket and they don't understand some of the subtleties. But the truth about Hadoop is that there are really sort of two fundamental layers. There's the data management and storage layer, the sort of infrastructure layer that the IT guys have to worry about. And then there's the sort of analytics and use layer, and that's where you guys come in. You need to get plugged into this layer in a way that you can do sort of cool stuff on it. So we start with unstructured and structured data, all that data that's out there either within the organization. We've heard speakers talk about sort of public data and markets emerging. So imagine all that data that you've got in your organization and that's available to you from these emerging data marketplaces making its way onto Hadoop. So Hadoop becomes the platform onto which you aggregate all your organization's data and additional data from partners and marketplaces, if you like. And the sort of core big data management layer of Hadoop is really the province of those sort of IT administrators in your organization. Their job is to get the data on there. Their job is to sort of look at, how do they sort of schedule workflows and applications that are going to run on this distributed architecture? What kind of tools do they need? I'll come back to the NoSQL thing in a moment. But so what? So you've put some infrastructure in place, you got the data on it. You've got to do something with the data. And one of the things that I think people have started to recognize more over the past 12 months is that there's another layer. All of you guys, some of you may be friendly with that sort of dollar prompt on a command line, but you don't really want to have to read a 1,000-page book or get in at a Java level if you want to apply your skills. So there's another layer, this big analytics layer that is starting to become available with technologies and products that is available to you to move your skills into this big analytics arena sitting on top of Hadoop's big data. And then, okay, so you've got data and you've figured out some insights that have value in the organization. Then you've got to look at operationalizing that. And operationalization of that typically means taking those results, putting into some kind of operational database. It might be a historical MySQL thing. It might be an MPP database. Increasingly, it's a NoSQL database. And it's those databases that sit behind sort of the customer-facing web applications and are often the interfaces to sort of traditional BI and visualization tools. So I put this together, hopefully, just to kind of create a map and a framework for how to think about sort of the macro components, if you like, in a sort of in a new Hadoop world. And then the final sort of couple of points are that low layer is not about you guys. That low layer is about the IT administrators and operators, but what you should care about is that upper layer and what you can get access to with these new technologies and tools by applying your skills through big analytics capabilities sitting on Hadoop. So let me give you kind of a tour and sort of a tip of the hat to the open source community and the Apache Software Foundation in particular. So Hadoop is actually a collection of open source projects. There's this vibrant community of hundreds, if not thousands of committers working 24 hours a day, 7 days a week, creating the set of technologies that make up Hadoop. But again, there's sort of two layers to think about there. There's the infrastructure layers, there's the core distributed file system, the MapReduce component, the things the IT guys need, some of these new NoSQL databases as well. But then there's a sort of analytics layer, which is where you guys are all interested in, sort of being able to take SQL capabilities and apply them through open source projects like Hive, to be able to pipeline applications through languages like Pig, and to look at predictive analytics through projects like Mahout. So for those of you who are interested in sort of digging in and sort of getting an idea of the open source projects, these are some of the ones to pay attention to, and we should all continue to give thanks to the open source contributors and the Apache Software Foundation. Now, when you're thinking about companies in this space, this is again an area where we see people sort of, when they're new, don't really understand how to think about this sort of Hadoop ecosystem. And the truth is that large companies like EMC with their announcement, the Greenplum Hadoop this week, but a lot of large companies, a lot of small companies, a lot of investors are driving huge amounts of money into this ecosystem. They're driving that money into this ecosystem because they see the problem that organizations have with big data and the opportunity that Hadoop represents. But there really is a whole ecosystem that is developing, which is good news for you because there is choice and there is competition and there is innovation coming not just from the open source community, but from commercial companies. So at the bottom level, you've got the data management layer. You've got companies who are taking Hadoop distributions, adding value with incremental capabilities and services, and saying, hey, you've got a choice down at this layer. You've got companies providing mechanisms to get data into and out of Hadoop with data integration and ETL. But on top of that, you've got to worry about how do you plug your skills into this environment? How do you plug your developers in? How do you data scientists get access with familiar skill sets? And this is sort of the one call out to my company. That's where we sort of sit. We're focused on you and developers and organizations and what you need to do your jobs on Hadoop. And then at an even higher level, there are sort of visualization companies who are saying, well, how do we present this to sort of higher level business users? How do we take existing BI products? How do we put new user interfaces and exciting visualizations on top of this? And I've got some of the companies listed there. And then I think the service organizations are really important because we all need help. We all need to learn. And I encourage all of you to look at this ecosystem in terms of hardware, software, and service vendors. And when you move to Hadoop, consider everybody who's in this ecosystem because they're not just with products, but with services to help you. So let me move into kind of just a distillation of the lessons that we've learned from our sort of users and customers and immersion in the Hadoop space over the past couple of years. A year ago, when I reflected on this was really how people were traveling sort of in Hadoop. They were getting to their destination, but it wasn't the most comfortable ride in the world because you really did have to be a rocket scientist. You really did have to read those long books and, in many cases, read the source code to understand this thing called MapReduce. People got to where they wanted to be, and what was encouraging was that even with the kind of clunkiness of this thing, they were getting very exciting results and moving from prototype projects into production. But it's now possible to actually travel like this with Hadoop, and that's again due to the work of the open source movement, the Apache Software Foundation, and commercial companies who are looking at the problems that people have had and looking at how can we make this a more comfortable ride? How can we enable you to go faster? How can we enable you to take existing skill sets and move them onto this thing called Hadoop? So I've sort of distilled what we've learned into, I think, sort of 5 holistic lessons. Paul will talk sort of more in the trenches about sort of the lessons from a practitioner, but this is kind of what we've learned from our customers. So number 1, plan. A lot of the people who were early were like, we're going to jump in with 2 feet and suddenly found themselves 10 feet underwater. They swam, they made progress, but plan. But don't boil the ocean. Don't take all your data and think, oh my, we're going to create some massive 3, 6, 9-month project. Find a meaningful set of data, make it a short project, and look for help, because help's out there. You don't have to do this all yourself. There are resources, as I mentioned. And then there's not just wisdom in crowds, there's wisdom in the cloud as well. So what companies like Amazon have done, taking their EC2 and S3 infrastructure and saying, we believe so much in Hadoop that we're going to create an on-demand service that's available. You don't even have to go install the infrastructure. You don't have to make that CapEx investment. You can spin up a Hadoop cluster and spend 10 cents and have several minutes or several hours of cycles on a Hadoop cluster. And if you've already got data on S3, then you can actually start processing that data on S3 today. We've got customers who've got 5, 6 years of web logs, for example, on S3. With the Elastic MapReduce service, suddenly what they can do is basically do large-scale analytics with products on top of that very easily with the data in situ where it already is. So lesson number 1, plan. Lesson number 2, democratize. So in early technology environments, what you often see is those kind of really smart people getting excited and sort of, I'm the guy who understands it. They really are the rocket scientists, and we owe them a debt of thanks. But if we're going to move access to this data to the people who sort of really need to do things with it and extract value from it, you have to find ways to connect the data professionals, the data scientists to it. So make sure that early on you pat the DevOps teams on the back and say, that's all very nice, but I don't want to program in Java. Please give me something. So their job really is to get that infrastructure in place, to get the data on it, to make you happy, but also to give you access to it. So think about democratization. Make sure you equip the right people with the right tools. So your DevOps teams may be really happy with sort of those dollar or hash prompts and command line interfaces and SSH interfaces and sort of crude rudimentary web interfaces, but the truth is that the right tools are starting to emerge. So, and those tools are connecting existing skill sets with the data. And I don't mean to demean any of you who love your VI and Emacs and command line prompts and SSHs, but there is a set of additional capabilities that allow you to go faster out there. Begin. This isn't about waiting around. Other people are not waiting around. People have extracted and sort of optimized their businesses today to death. The one remaining area where they have not optimized is looking at the value that's locked up in their data sets. So businesses who are recognizing this are running, and they're running fast. So they are beginning, and believe it if you don't already, your competitors are doing this. Finally, once you've begun, don't stop. So back to my point about sort of this conference and the velocity at which people are operating in this space, once you've kind of got that meaningful set of results from a short project, then look at how you get to the next stage. Keep planning, look at how you can go faster. So hopefully what I've done is kind of given you a sense, again, a distillation from our customers of sort of what we've learned. Tried to help you a little think through the justifications, given you some frameworks for how to think about this, and at least a sort of holistic set of ways to kind of get started. And so hopefully this has been useful. And at this point, I think I'm going to pass over to Paul.
All right. Thanks. So I'm going to take it from there, and the last couple points that Martin made are good ones, in that you got to start now and you got to go fast. And the question is what does fast mean, right? And we're here at a data science conference, and science is an endeavor to discover knowledge, right? And I think the implication, or what a lot of people assume, is that the knowledge you're discovering from big data is insights about the real world. And that's true, but something more fundamental and more important to your competitive advantage in whatever it is you do is these techniques and these procedures and the input data, and knowing how to string them together to do something that provides impact to your business, right? Knowing that I can take these 3 data sets, mash them up in this way, put them in this database, and provide them to either a customer or to an analyst in my business. I mean, you can write that answer down on the back of a business card. That's much more valuable, because that's something that you can optimize, something that has impact on your bottom line. So what data science is, as I see it, is the exploration and discovering what those things are. And why Hadoop has been so game-changing, frankly, is that it has dramatically lowered the cost to conduct basic experiments, right? You have a hypothesis that a certain data set or a certain mashup will have impact, and you have a hypothesis not only about perhaps the statistical properties of the data or the size of the data or whether or not I can do something, but you also have a hypothesis about whether or not anyone even cares, right? I think that a lot of the mashup talks spoke to this a lot. There was a lot of mashups that they said, well, we didn't even know if anyone cared, but we just tried it, right? And the fact is that it was so cheap, and it was so it's tractable to do those things because you have Hadoop, and that's Hadoop. And I want to talk about a few things during my talk about more specific ways that Hadoop has changed the game in the Hadoop ecosystem. And this is just more to that point, is that Hadoop may not be perfect for a lot of things, but it's a great multi-purpose tool for exploring the big data space and exploring how big data can have impact on your business. So there it is. The Hadoop is the multi-purpose tool. It's the game changer. And I'm not talking about just Hadoop. I'm talking about NoSQL databases. I'm talking about the infrastructure around it. But it's the idea of lowering the cost and being able to do, being able to scale in multiple dimensions, as we say, as Martin said in his slide. You're not only scaling in the size of the data, the data that's crippling your Oracle database or your existing infrastructure, but you're scaling in the complexity of the data. Being able to do mashups, being able to put all of your disparate data sets on a single system and then having that at your fingertips and then being able to explore that quickly is why Hadoop has been so meaningful to us for the last 5 years or 4 years now. And just to briefly touch on it, and I can't go, in a short talk like this, I can't go too in depth about why it's a game changer and why technically it works. But the point is, and I think Pete mentioned this earlier, is that Hadoop is built to maximize disk I/O, run on commodity hardware, and it's built to scale, right? So kind of having those three core principles gives you the assurance that you can use this long into the future and things like this into the future. And so with Hadoop, and the question is how do you use Hadoop, right? So I have this thing that can cull through my data really fast, and I have the ability to do quick lookups in a structured table. And those are kind of the two core tools, and you can play those off each other, right? So NoSQL is, and someone said yesterday, they talked about the hunting and pecking the way it used to be. You can't summarize, you can't look through all the data for the big picture. Well, NoSQL fundamentally kind of is still that hunting and pecking. But if you kind of know where you want to look, that's good. And NoSQL allows you to do that fast. It allows you to support many more users than something like MapReduce, right? Which is much slower, right? But it's fundamentally much more powerful analytically in that you can go through all the data, right? And I kind of have this analogy that I've used for a long time is that databases in general are the speedboats, right? If you want to get from point A to point B very fast, only take 3 people, you want a speedboat. But if you want to haul, 1,000 tons of something across the ocean or from one place to another, you might want to use a tugboat, right? They both have their purposes, and you can, and in a broader picture in terms of trying to impact your business, you're going to want to play those off each other. So the most powerful applications and a lot of the mashups that we've seen and a lot of the other things we've seen are basically leverage both of these capabilities off of each other. And so what I'm going to do is I'm going to talk about kind of two, a little bit later on, two kind of step through those things. So here I took Martin's diagram and kind of stepped through how would you get started, right? You buy a Hadoop cluster and you want to jump in with both feet. What do? Well, you buy it, and the first step is you put all your data in Hadoop, okay? It's just a file system. It's like putting it on a SAN, okay? Next step is you might do some big data analytics, right? You might do a couple MapReduce jobs or maybe a pig thing or something. But the idea is to do something that is it's usually pretty algorithmically simple. That density map we saw of San Francisco is a classic example, right? I'm sure it was probably conditional density or something, but relatively straightforward and very powerful, and something that you couldn't do unless you kind of looked at the data in aggregate, right? And the second step is kind of, from a business perspective, kind of pays the bills, right? You've invested a little bit in Hadoop. It's like, well, what am I going to get out of it? Well, you can try to get something out of it relatively quickly just by doing a big data analytic, maybe creating some sort of, some fancy picture or something, provide some sort of high-level insight, right? Then the next step is to then put all your structured and maybe even unstructured data in some sort of NoSQL database, right? Again, you've already got all the raw data on Hadoop. Now let's kind of make all that data live. Make that, serve that up through an API or whatever, or some sort of basic search through some sort of NoSQL database. And I'm not saying something, an exhaustive analytic engine on top of all of your data. Just something simple. You can ask general questions like, is it in here? Is there something in here about certain things? Basic indexes, right? And then step 4, which I think is really where you start having a really large impact, is kind of what we call pre-computation, right? And that is the idea is that you take the output of big data analytics and you put it into NoSQL, and then you serve that up for folks. And I'm going to talk a little bit more about that later. But going back to this step, this is kind of kind of go into depth a little bit on this, and that is that there's lots of structured data, and this is kind of one of the points I wanted to make on this, and this is, we see this 9 times out of 10 when we work with a client. This is kind of the first thing that they want to do, right, after they just put all the data in Hadoop. And that is you always have a wide range of structured data, right? And it's, and I got some examples here. Genomics data is a whole set of things, right? You got clinical trials data. You've got, lots of, intrusion network events. You've got web logs. You've got, if you're a social network, you've got all sorts of graph data. You've got, all these sensors, all this data coming in. And there's this sense that there's a lot of value that can be gleaned from that data, but they want to just do basic queries, but they're overwhelmed, and they basically end up putting all these stovepipe databases, and there's no way to draw connections against those, get the network effects of combining the different data sets. So with Hadoop and NoSQL and a schemaless database, you can kind of make an attempt to have an anti-stovepipe, put all the data in one place and be able to analyze it in aggregate, right? And kind of the one thing that you try to do is I call it the Heisenberg principle of data, right? Which is, don't mess with the data. Only modify the data as little as possible to get it into the database. And with NoSQL, you can do it with very little modification. So just don't mess with the data. You're going to run it in a NoSQL database, and hence it's running on Hadoop. Hence it's scalable, so you can kind of do a trade-off. You can do stupid things with your labels and various other things that traditional database folks are going to want to optimize. They're going to say, well, I had one example where someone wanted to say, well, I think the name of your, the name of this column is too long or something like that. And it's like, it doesn't matter. It's getting compressed anyway, right? But the point is you can scale in the size and the complexity of your data. So, and the bottom line is that a change in the data here, say I add to my patient histories, or I have a new database or whatever, requires no change here, right? And that's kind of fundamental, because in a lot of cases, the data, you have your 5 data flows going into your database. Even if you don't think you're modifying that data, the data is changing underneath you as things evolve, right? So we're basically claiming that you can kind of build the anti-stovepipe. You can add new data sets, you can modify existing ones, and you can put all your data in the same place, and it's relatively easy. So that's kind of one real good use case. So talking about something more specific, maybe put some concreteness to this, is talking about exploring new ways of using network defense data to detect intrusions, right? And it's kind of the poster child of big data problems, right? I have tons of data, right, all throughout my network. It's always changing, right? There's always new ways, new summaries, new malwares I need to look for, various other things, and the threat is constantly evolving, right? So how do I use big data technologies to keep up with this, right? Well, the first step is you do ad hoc analysis. You do MapReduce jobs. They take, maybe they take 1 day to do an experiment. That's being conservative. It should probably take less. But if you're doing it in an Oracle database or some more relational database, it may make weeks to do an experiment. So you can do your ad hoc analysis. You can discover your new patterns with threat vectors quickly, and then you can quickly port them over to some sort of NoSQL database linked to a user interface. And frankly, this is still part of the experiment, because you don't know if the person that is sitting there in the middle of the night looking at your network is going to find this useful. So you put it in a user interface. It's all low cost. It's basically a mashup, right? And you can quickly evolve to get to something that is very meaningful. And this is an example here where what we did was we took some NetFlow data and we did some clustering, and you look for some anomalies, and and it was an algorithm that we were experimenting with, and it was relatively inexpensive. We then came up with a classifier for anomalies, put some live data in it, put it in a cool user interface, and then we were able to try it out with real analysts, right? And to do this with traditional IT, planning ahead of time, saying, okay, we got to run this thing, we're gonna have this much data, speccing it all out would have taken months, whereas with Hadoop and the idea that we can scale and not have to worry about a lot of that stuff, we could do it in a matter of days. So that's one example, and it's game changing for a variety of ways. But the primary one is that you're being able to explore this data at the speed at which it is changing, and the speed at which you need to in order to keep up in this world. So another example, and something I'm personally very excited about, because it is very, it's hard to wrap your head around the implications, is the idea of pre-computation. And this is the most classic example, is if you know, Google Suggest, right? It's pre-computed the answers, and it auto-completes your sentences as you type them in. And this is presumably, I mean, I don't have any insider knowledge, but presumably this is a result of a large-scale data analysis where they said, what's the most likely search query given the first 10 characters, right? And everyone's experienced this, and it's somewhat useful, and it's fast, and it's basically the idea is that you do big data analysis, you then put that in some sort of NoSQL database or some sort of lookup database, and then you get a cool a useful tool at the end. So something a little more in depth is this idea of biometric identity scanning. It's just something that we've done, right? And so a little background on how this works, right? So if you're looking at fingerprints, there's kind of 3 things that you do with fingerprints, right? Enrollment is the idea that you go to the police station or whatever, and they take your fingerprint and then they put it in the database, right? And then they associate it with your name and whatever else. And then there's verification, right? So you go to a customs, or you go through customs or wherever it is where they do this, right? And you say, here's my credentials, I'm Paul Brown, and then they scan your fingerprint, and then they compare it with the fingerprint in the database, and they go, yes, that's you, and they have some sort of algorithmic way to match those two up to verify your identity. But then the question comes in, well, what about all the fingerprints in the database, right? So maybe I have multiple fake identities, right? And I have 3 passports and 2 of them in my pocket, and I'm showing you this one. How do I verify that this is not going on? And doing that at a low latency is difficult, doing traditional architecture. So we said, well, let's take a shot at it using these 2 tools, right? NoSQL and MapReduce, right? So what we did was, well, then there's another problem too, which is that the fingerprints, it's got to be a fuzzy match anyway. The first time they scan it and the second time they scan it, it's going to look a little different. So it's a little tricky. So the idea is we thought, well, what if we could do some pre-computation? We could analyze all the fingerprints in the corpus of fingerprint databases, basically do some sort of pre-computation that would allow us to suggest ahead of time, very quickly, a subset of fingerprints that most likely match this one, right? So to effectively narrow the search space, right? Because you can imagine if it's a fuzzy match, I can't do an index lookup. So what I have to do is I have to scan through every fingerprint, comparing this fingerprint to the entire database. If I can do some sort of pre-computation, instead of having to scan through 10 million fingerprints, only scan through 1,000, I can now do it in a reasonable amount of time. And that's basically what we have to do. The mathematics behind actually doing that is, it's debatable, right? And it's something that could evolve over time. This is what we did. We just did some clustering using Mahout, and then we actually wrote our own little NoSQL-like database because we needed to be able to apply kind of these biometric functions within the scanner. But the idea is that this isn't the end-all algorithm, but the idea is we could try it and see how it worked, and maybe even try it in the real world or in some sort of experiment. And this is a little bit more about the piece of software we wrote. But the idea is we were able to test that, and we were able to dramatically lower the amount of time to do a one-to-many match of a fingerprint, right? And the idea is that this plays both with MapReduce and with NoSQL, right? And you're playing those 2 things off each other. And in an exciting world with all those different data sets, it's exciting to me that there's this kind of endless possibilities of things we can do. So some lessons learned in Hadoop. And I think I'm going to say a few things that have already been said, is that, and this is, Hadoop is very accessible, right? That was one of the things that I remember first about Hadoop was, it was amazing. People would say, I downloaded it and I got it working in an hour, and I'm doing MapReduce an hour later. And this was in, late 2007. At the same time, it's very difficult to tweak and customize for your own purposes, right? To really make it go fast enough that it needs to go and various other things. And to that end, talent in this area is also very, very rare. And at Booz Allen, we're looking to this ecosystem that Martin talked about to evolve to the point where we don't need as much of that data talent. We can really talk more about data scientists, right? Thinking about the algorithms, thinking about implications in culture and various other things, and not have to worry about the low-level stuff. This is another one that's really kind of a core principle is modify the data as little as possible. And frankly, for two reasons. One is now you can, because you have a scalable storage. So you can just keep an original copy of everything, and then you can make as many subcopies that are slightly tweaked as you want. And do your prototypes at scale. And the reason you want to modify it as little as possible, because during this exploration, if you've modified the data, I guarantee you'll find very quickly that you've removed some piece of information that you want. So it just happens that way, right? And then agility is the key to success. You know, again, this is the point, is that the faster you can go, the faster you can adapt to the changing environment, the better. And then drive towards generalized components. And this is one thing that there's kind of this debate. It's not really a debate, but you have Google's approach is to kind of keep a lot of this secret, the way they do things, at least the underlying architecture. Whereas Facebook is kind of saying, well, we're going to open it up. Now they have a business reasons behind that, but what I like to tell clients is that you're a really fast and innovative architecture that's better than everyone else's is only going to give you a short-term advantage in this space, because the technology is improving so quickly, and you're not going to be able to keep up with this ecosystem. However, that tradecraft, knowing what to do with it and how it impacts your business model, that's a lasting strategic advantage. And so when you're thinking about this, use as much of an existing product as you can so that you can focus your own resources on the things that are most valuable to you. So that's what I have here. Is that cloud computing is a good example of that, right? You can use, Martin mentioned Amazon. If you can do all your stuff on Amazon, you're great, right? So it's commodity hardware. You can either use cloud, you can use commodity hardware. There's going to be, Martin's got stuff going with pre-canned analytics and user interfaces, and all that stuff is going to dramatically continue to lower the cost of doing cloud computing. So some thoughts on the future of big data. The first is, this is personal, I'm really glad we don't call it cloud anymore, right? And because it is different. They're basically orthogonal things that working together are very powerful, but they are fundamentally different things, and it's nice to be able to talk about that. There's a healthy and growing big data ecosystem, and the cost of ownership is continuing to drop, and it will. But as Martin said, you know what? When to jump in depends on your own risk and reward analysis. If you come in too late, you're going to get beat by your competition, and if you come in too early, you may waste some time. But going into the future, once all that's solved and you're rocking on your data, and you're turning data into knowledge, some things are going to happen. You're going to need more data scientists, not more Hadoop experts, but you're going to need more people that know what's in your data and what needs to be done with it. You're going to run into a problem with sharing of this data at scale. You're going to run into privacy legal issues, and you're going to eventually become hungry for more data. So that's what I have. 30 seconds late.